Good afternoon, everyone, and welcome to another Tech Talk. This one's really exciting. My name is Jamie Trujillo. I will be moderating for our presenter, Jane Colhoun, and this is on moving number talks online. So if you are watching this recording, you will have the opportunity to contact us afterward if you have any questions. And for our active participants, if you have any questions, please feel free to use the chat. And with that, I will turn it over to Jane.
Great. Thank you so much, Jamie. So as Jamie said, I'm Jane Colhoun. I am a mathematics educator in Taos. I have been a full-time lecturer at UNM Taos, and I have worked with the Taos Education Career Center as an HSC mathematics instructor for over 12 years now. So I really enjoy math, and what has been most captivating to me is the idea of number sense. So that's what this focus is about, is how can we increase the number sense and using number talks to do so in this new online environment, whether it be synchronous or asynchronous. So before we describe that, let's make sure that we know what a number talk is. So a number talk was, number talks were developed by Ruth Parker and Kathy Humphrey. And they are very short mathematical dialogues that usually take anywhere from 5 to 15 minutes. So the nature of that being very brief but deep is that you can pretty much fit them in anywhere in your curriculum. So it's not a big time commitment. So it is a mental math activity, and it builds number flexibility and number sense. So the advantage of that is that studies show that students that have number sense, they can solve problems in alternate methods, visually, mentally, and they learn how to verify their answers to justify them so that they make sense. Which, when we think about mathematical practices, that is ultimately our goal, is it not, as math teachers? So I want to show you a little bit of a video that was part of a course that I also highly recommend and have done a tech talk on in the past. I think it was another conference I'd done as well. It's a course called How to Learn Math, and it is actually a free MOOC, a multi-open online course that's offered through Stanford University. And there's one for students that I actually do give students. It's a requirement, an assignment in my courses. And this particular video that I'm going to share to introduce number talks is a portion from the How to Learn Math for Teachers and Parents. So Jo Boaler is a wonderful math educator that you may be familiar with if you're a math teacher, and she is from Stanford. So let's take a look at her. I can find that here and share it properly. Okay, so here we go.
So one of the best ways to teach number sense is a pedagogical strategy that's been really growing over recent years as a kind of grassroots movement called number talks. Sometimes they're called math talks. And they were started by Ruth Parker and Kathy Richardson. You may use these already, but I know many people don't, and we're going to try one together in a moment. The way they work is, in a classroom, you would ask students to work out a problem mentally in their heads without written work, without writing. And when they've answered the problem, students are asked to just put up their thumb. No hands, because when students are putting their hands up as soon as they're finished, it's intimidating for people who haven't finished. I'm going to just show you the way a number talk is introduced, just the first piece now with the use of thumbs. So this was a number talk that Kathy Humphreys gave to our elementary teachers at Stanford. And we're just going to watch the beginning here to see how a number talk is started.
Okay, so on this card there are some shapes. And when I put the card up, I'd like you to figure out how many there are without counting one by one. So take a quick glimpse of them. And when you do think you know how many there are, then put your thumb up to show me. Ready?
So before we watch a couple of different number talks, I want to try some of the mathematical ideas with you together. So the first thing I'm going to ask you is just simply to write down the answer without using pen and paper. Try not to use the traditional algorithm, but work out and write down the answer for 18 times 5.
So guess what I'm going to ask you to do? I'm going to pause this video and ask that anybody that's here can go ahead and put in the chat what you get mentally as the answer for 18 times 5. And again, resist using the typical algorithm. So Jamie, since you're seeing the chat, you can let me know when we have a couple answers.
Definitely. Okay, yes, we got both of our participants that we currently have, they both said 90.
Great. Do you have an answer, Jamie? Do you agree?
I do agree. Yes, I do.
Okay. So let's see what continues here with the video, and we'll come back to those results. And there's never a wrong answer in a number talk. I just want to kind of point that out.
So you probably got that the answer is 90. But the answer is probably not the most interesting part. The most interesting part of number talks is really thinking about how you arrived at that answer. As of course, number problems can be seen in many different ways. And it turns out that not only are students fascinated by the different methods, but they really learn a lot from thinking about the methods, about how and why they work. So we're going to hear now from some Stanford students who were asked to solve this problem and hear the different methods they used.
That would be 90.
Okay, and how did you get 90?
Well, first I doubled 18, getting 36, then I doubled that, getting 72, and then I added 18 again, so
Okay,
that was fun.
90.
and how did you do that?
So I take 18 and I have that. 9 times 5, 45. 9 times 5, 45. Add them together, 90.
18 times 5 is 80.
How'd you get 80?
5 times 10 plus 5 times 8. No, 90.
90.
And can you just describe your method of how you got to that?
I did 9 times 10 instead of 18 times 5, because same thing.
Well, I'll do it out loud then. 18 times 5. Okay, hopefully I don't get this wrong as I'm doing it. I do 20 times 5, so 2 times 5 is 10, add a 0. 2 times 5, that'd be 100. And then minus 2 times 5 again. So that would be minus 10, that'd be 90, I think. But I might have gotten that wrong. Okay, good.
18 times 5. Okay, that's 90. Yeah.
So how did you reach that?
Honestly, I tried doing like, you know, the whole 18 and then 5 under and like 8 times 5. And then I realized that it's easier to just do, okay, well, first of all, you are doing 8 times 5, which is 40. And then if you do the 1 times 5, which is actually 10 times 5, that's the 50, and you just add them together, which is the 90. But those are little numbers. Like, I wouldn't be able to do big numbers.
Okay, that's 90 because 18 over 2 is 8 times 10. I mean 9. It's 18 over 2 is 9 times 10, which is 90.
90. So how did you reach it?
Well, to do it quickly, I separated it into 10 and 8. So 5 times 10 is easy, that's 50, and then 5 times 8 is 40, and then you just add them together.
I feel like I should be able to answer 18 times 5 pretty quickly, but I can't. It takes a while. I do know it's 90. I think I'd probably do it with the 18 on top and then the 5 on the bottom, and then 5 times 8 and 5 times 1, and then add it together. It's probably a pretty slow way of doing it.
So one thing that's nice about number talks is the solutions, the different methods that are used can be drawn in these different ways. So I'm going to draw out here the different ways the students that we just saw solved this problem. So we can also visually represent the students' methods, and I'm not going to do all of them, but you may want to visually represent them all. It's a really good thing to do. So I might represent Neil's method. He didn't work out 18 times 5. He worked out 9 times 5 and 9 times 5 in this way. Whereas Casey divided her 18 into 9 and multiplied the 5 by 2 to make it 10. So she worked out 9 times 10, which I might represent in this way. Sammy broke the 18 into 10 and 8 and multiplied it in that way. Whereas Jamie made the 18 into a 20 and then subtracted the extra 2 times 5, which I would represent in that way. And there were some other methods. Maybe you can visually represent those.
So I want to stop here. There's more of this video, and I'm glad to share where I found this. Actually, it is a resource on my last slide. But I want you to take a look, if you can, at the 4 visual representations of the solution of 90. And we have Neil, we have Casey, we have Sammy, and we have Jamie. So if you could, in the chat, for those of you that are here live, let me know if that image, one of those images, one of those people by naming them, Neil, Casey, Sammy, or Jamie, is the way in which you visualized it. If it's not up there as a visual representation, you can write other, and I would love to hear your solution.
So Kylie says Sammy. Sammy was the way that she did that.
Okay.
Can I tell you that oddly enough, mine was Jamie?
Oh, that's so funny, Jamie. Well, of course it was.
That was so strange.
How did they know?
Kylie also says that she liked Casey's method as well.
Mm-hmm, mm-hmm. And did Bill have a method that matched or other?
Bill has not answered.
Sometimes it's hard to find the visual.
Okay, so Bill says Sammy, but also Neil's was interesting.
Mm-hmm, mm-hmm. And what's interesting to me as an instructor is when I've done this and tried to capture. So imagine being metacognitive about presenting these, not just as a student, which you just participated as, but when you think about it from an instructor's point of view, sometimes capturing these and explicitly showing the method is one of the most challenging parts, but it's also one of the most rewarding parts. So you want to be able to strive to capture the thinking of your students when they share their methodology with you. And for instance, when I look at Neil's, I can't actually, even though I've watched this video and prepared for this presentation, which person was Neil? I'm not quite sure. But when I look at that Neil image, I think of the person who said 18 over 2 times 5. So I wondered if that's the one that captured that. So there is some videos that are in our resource center on the last slide that have some examples of this that talk about the challenges that teachers can face when they are indeed moving into using these more often, because sometimes we have difficulty capturing visually what a student is sharing. So this is the basic idea of a number talk. So let me go back here to my slides and say, now that we understand the basics, how do we capture this in an online environment? Because now that once I have recently in the last couple of years been using these number talks as a closing activity for my classes, it became just a routine that I would do puzzles or questions like that. And the students became more and more comfortable in that environment. It became very engaging and dynamic. And I really love that the students who were very quiet had that strength to be able to really take their time. If you noticed in the video we just watched, there was that one student at the end that was concerned that it should be faster. As we know, as educators in the mathematics field, that speed is not the important part. Mathematicians are not fast problem solvers all the time. We want to think deeply about these problems. So this particular format allows us that opportunity to be able to have every student kind of think at their own pace, and students that have discovered one method have time while the others are thinking to think up alternate ones. So it's really important to think, now that I've realized and really felt the benefit to my students with this particular tool, how can I bring that now that we have moved in an online setting? So as we know, we have 2 possibilities in online. I know there's lots of terminology that we're learning: blended, remote, remote arranged. We have asynchronous and synchronous. So I'm going to focus on these 2 ideas. Asynchronous is when we are not together in space and time at the same instant. So asynchronous is not being together. So those of you that are watching this after the recording is posted, you're in an asynchronous environment. So you're watching it at your own times. Synchronous, however, is what we're doing right now with the participants in this particular Google Meet. So it's at the same time in the same place. So most of my classes currently at the university are asynchronous. So what I have done to capture this in an online setting is I use discussion boards or some type of open forum in my learning management system. Now, my learning management system is Blackboard Learn. So you may be using Google Classroom, Canvas, Moodle, I don't know, there's so many. So what particular tools you have, I'm curious, and I am going to ask that you share that towards the end of our presentation here. But for now, I wanted to just show you what I've done in my courses in the synchronous, in the asynchronous way, how I've taken advantage of this particular tool to go ahead and move this in an online format. So here is one of my classes that I teach, and this is my UNM Learn course shell. So I have my my welcome, of course, and I do a modularized setup. However you set this up is irrelevant. I'm not advocating for one way or another. What I do want to show you is I started here in Unit 2 after they were oriented and had done journal entries and other orientation introduction discussion posts. And I decided to move the number talks online. So what I call them in my class is maths and logic discussions. So if it will not let me, will it not let me? Oh, because I'm not in student view. Well, it doesn't matter. We're all teachers here. So here is my maths and logic discussion. So what I did is I found a math puzzle and I put it as a discussion post. So in this particular learning management system in Blackboard Learn, when I create this, I can create the setting so that a student must create an original thread before they can see other people's responses. So in a number talk, which I'll show you another video I created, but the idea is everybody has private think time. So they get the chance to take their time with the thinking. Now, this is a huge advantage when we are in an asynchronous environment because people are doing this at their own pace. So a student may do one post on Monday and another student may not answer this particular discussion post until Wednesday. And there's no detriment to that. Everybody has their time to sit and think with it. Some person may take 10 minutes to answer, another person may take 2 hours. So you really open up that potential for a deep thought process with the student without the pressure of performing at a fast speed. So when you have a student required to create an original post, that's their way of saying thumbs up. And then once everybody has an answer, they can open up and see who's already shared. So this particular one is a system of equations for those of you who've seen it. Now this is very easy to find these puzzles if you don't have some favorites already by just typing in math riddles or math puzzles and looking at the images in a Google search. So what this did in my class is it really allowed the students to explore without fear of risk for being wrong, what they thought the process might be, to share their thoughts in an individual, unique post. And then it opens up the ability for them to see other students. And a lot of students had this incorrect. And this was my first one for a reason. Some mathematical practices that we know are attention to detail or precision, right? So if you look at this, I don't know if it's big enough here to see, but if you look at this particular one, and you've probably seen these on Facebook, sometimes there's like math battles on Facebook posts about these kinds of questions. I don't know if you've seen that ever or not, but
I have, yes.
You have, yes. So sometimes there's just a slight little thing that's kind of like a trick and people get kind of hung up on it and they, so here, everything's addition, 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 addition until the last row where there's this little multiplication. A lot of people miss that. Another thing is this particular man, which I love. One of my Pueblo students called this the census man, which was very timely for the time of year I presented it. And he said he noticed the census man, but at the end, if you notice, the guy has a little key on his clipboard. So it took a lot of iterations of discussion post conversations for people to say, actually, I didn't get the same answer as you. And it became this online engaging dialogue between my students. And I stepped back and I let them discuss this with each other. after the deadline, like I think it was the day of the deadline had approached for this assignment when it was due, I had written out my explanation based on the feedback I had from my students. So I have a document camera and I can capture my images. But even if you were to just write it out and use Cam Scanner, if those of you who don't know Cam Scanner, please Google it. It's an amazing tool on your phone. You turn any picture into a PDF. So if you do that, you can write out your solution and your thinking on a problem and then scan it and upload it to share with your students. So I did that on this one, but I used methods that I had already read and engaged with my student dialogue conversations. Some of them had seen the two things together, the census man and the key, as being multiplication. Other thought it was addition. So there was different interpretations of this that allowed me the opportunity to show, depending on how you interpreted this question, this might be a solution you could imagine. And depending if you interpreted the equation this way, this might be a solution you imagined. So it gave us an opportunity to have alternate interpretations and alternate representations. So this was my first foray into really doing it this semester in this way. So that was my unit 2. And then, if I can go back. In unit 3, I provided another opportunity in my maths and logics discussion where we're talking about sequence and series and sums. So we have this particular, just a makeshift string of numbers 1 through 20. And my question was, for the sequence of numbers from 1 to 20, find the sum, but you have to be able to explain the way in which you did this. And I left it very open. So I had, as you can imagine, some very varied responses, some very interesting responses. Now, for those of you that are here, I suspect there's probably 5 ways you could think of doing this individually. So that would give us 25 ways right off the bat if we all just kind of expressed 5 unique ways. And that's what allowing your number talks to go online really cultivates, is this alternate representation for number sense. And interestingly enough, I had students who did do, perhaps think about it for a second what you would do. I had students who did do the obvious, which is add 1 plus 2 plus 3 plus 4, which will totally work and get you the answer, which is 210. However, other students saw the possibility of doing what we call compatible pairs, the 1 and the 9, the 2 and the 8, the 3 and the 7, and so on. And they grouped numbers together, which is another number theory way that we as mathematical thinkers can find sums very quickly. Other people saw 19 and 1 as 20, 2 and 18 as 20, 17 and 3 as 20. I think I said those numbers wrong, but grouping up to groups of 20. And another option is to do 21 and 21s all the way till you get to the center. And I had one student, interestingly enough, who found the actual formula for adding a sequence of numbers. And they did this by researching online. And it was all became this very rich conversation between my students and their peers. So then I got really excited about this and I moved this on a little bit further and I said, well, I'm doing video lectures all the time and I'm doing my synchronous time with my other classes. Maybe I can do something like a number talk would be in a classroom. So in this week, where is it? Nope, not this week. Unit 4, excuse me. I had them create their own problem for their classmates in Unit 5, which is another interesting thing that is not part of this discussion today. Maths and Logic discussion Unit 4 was a number talk. So this is the first time I did a video number talk. So I just want to show you this because to kind of set up more of the rules too, which wasn't quite talked about by Joe Bowler in the previous video. So let's see if I can do this and share this screen. Hi, everybody, and welcome to Unit 4's Maths and Logic discussion. We're going to do something a little bit different this unit, and I'm going to do my best to encourage you all to experience a number talk, which is usually an activity in mental math that promotes fluency and diverse ways of solving problems. And it's usually done verbally in front of a class. And I'd ask a question, and there's no paper and no pencils and no calculators. And when I ask the question, all the students will mentally think of an answer. And I'll allow for everybody to have time to come up with their own answer. And the way I would know this was when you had an answer, you would take your hand and quietly give me a thumbs up that I knew you were done. And when you do this in a classroom, it allows the other students a chance to, without pressure, take their time to come up with an answer themselves. So if you already have your thumbs up and you're kind of waiting for the other students, you could think of a different way to mentally come up with an answer. And then you would give me another finger to show me you have two alternate diverse ways of solving the same problem. Maybe you have three. And then when everybody at least had one solution to the problem, I would call on the volunteers. I would ask, well, first of all, I would ask everybody their answer. So I would just ask for shouting out of answers. And I don't care if they're right or they're wrong. I would hear 12, 24, 37, 212 and a half. I don't know. There'd be just very, very many diverse different answers. And I'd write them on the board and just not have any attachment to which one's right or wrong, because that's not what the number talk's about. The number talk is about discovering ways in which you can do mental math and different alternate representations of problems to develop numeracy skills and fluency in mathematics. So once I had a list of potential answers that everybody had given one answer, at least, on the board, I would ask for people to volunteer to defend their answer. And in that defense, you would be asked to explain to me exactly how you came up with an answer. Now, here's an example. You guys all who have done the How to Learn Math course have seen a little bit of this in there. They asked a multiplication problem and they wanted you to do it mentally and come up with an answer, and they talked about different ways. That's what we're going to do this week. So you've seen it in the How to Learn Math course, so this hopefully will remind you of that. But as an example, if I were to ask you all to follow that protocol, do the mental math, do not use a calculator, do not use paper. Here's the thing, when I ask for your answers, and when you're gonna do this in a discussion post, okay? When I ask you to post your answer, I don't want to hear that you did it using the traditional algorithm of multiplication. I don't want to hear that you lined the numbers up and multiplied and carried and did partial products and added them together at the end. That's not what we're looking for. We're looking for alternate ways. So an example might be if I were to say, okay, everybody, we're doing a number talk. Everybody put your pencils and papers away, and mentally in your mind, show me a thumbs up when you have the answer to 9 times 12. I would give everybody time to come up with an answer, 9 times 12. And then I would have everybody shout out the answers. So what you're going to do in your discussion post is start off with your answer. And then you're going to explain to me the defense of your answer, exactly how you did it. Again, not the traditional algorithm way. I will not accept that as an answer. I want to hear that maybe for 9 times 12, you did 9 times 10 plus 9 times 2. Or, and I'm just throwing some of these out here without trying to jumble your mind about this. Or maybe you did 10 times 12 minus 1 times 9. I mean, there's different ways you can play with it. Maybe you added 12 to itself 9 times. Maybe you added 9 to itself 12 times. Something like that. Think of an alternative way, and I want to know your ways. And there's ways you can do it visually with circles and rectangles and dots and stars and arrays and window pane methods and all kinds of ways that you guys have done mental math. And I want to know the way that your first instincts, okay? Your first instincts, what was it? And I want to see if you can post yourself the original post and then go over and read your other classmates' answers to the problem I'm going to provide. And maybe that was your second way of thinking about it. Maybe you would have never thought of doing it the way they did it. I don't know what kind of conversations will come up from you guys. I'm excited to see it. So that's kind of the outline, the basic framework of doing number talks. They're to promote mental math. They're to allow everybody to have a chance to try a problem. They're to understand it's not always about the answer.
It's about the process to get to the answer, and it's to share alternate ways of coming to the same conclusion through justification. So here is your number talk for Unit 4. I would like everybody to respond in the discussion post their very first instincts way of how you come up with the answer for 13 times 29. Again, 13 times 29. Have some fun. Thanks.
So the idea there is just to kind of show you what I did. And that was my first one. So it was a little bit longer than I expect other people would probably have to do it. So I think the first time setting the stage for how to accomplish something that's maybe new to students, it takes a little bit longer to set it up. And then it becomes a norm and a classroom norm. So what I was able to do is actually in the next unit, I used another video number talk. And maybe some of you know this. I'm not going to share it for the sake of time. I want to hear what some of you do and talk a little bit about the synchronous settings. But what I did was used the Die Hard question just in the chat. Does anybody know what I'm talking about with the Die Hard math problem where there's a danger of the detonation of a bomb from the Die Hard movies with Bruce Willis?
Nobody has said anything yet. And no, Kylie, nope, we're getting no's. I have not heard of it. Yeah, Kylie says, no, tell me.
Oh my goodness. Okay, so I wasn't planning on doing this, but I'm going to see if I can find it because my video is too long, but I can at least show you where to find this. All I did was typed Die Hard puzzle, and you are going to see it's a water jug problem. So the challenge is you have a 3-gallon and a 5-gallon jug, and you need to figure out a way to get exactly 4 gallons. So it's a wonderful problem-solving situation, and it's set up in a movie that students may have seen. Now, as a preface and a warning, there is some swearing in here. Samuel Jackson's in here, so you can imagine. So you may want to judge your audience whether or not that would be offensive to them. So I don't always recommend this problem, but find some kind of problem. There's so many wonderful math movies that we could extract really rich conversations, potentially really rich dialogues with our students. So find a way in online settings to be creative, to bring this dialogue into our online classes. That's basically my point here. So definitely, if you're interested, take time after the webinar and go down a rabbit hole of the water jug problem. It's quite fun. So hopefully that gives you a little bit of insight there. So, okay, so that being said, the synchronous solutions is what we're doing right now. We're in a live web conferencing tool. We're using Google Meet right now. Perhaps you use Hangouts or Zoom or Kaltura or whatever, Collaborate, whatever tool your institution uses. You've got that synchronous option. And I've already used the chat as an example for you to see how you can incorporate a number talk into a synchronous setting. You guys were able to tell me your answers and identify which drawing represented, if any, your way of solving that problem. So that's an example modeling for you how you might do it in a synchronous class. Another thing, if you want to use the other tools besides just the chat, which has its limitations, you could, of course, use microphones and have students actually share verbally their thinking the way we saw in the startup video with Joe Bowler. Now, 2 other tools that I really like that can incorporate into a synchronous setting is Padlet or Google Drawings. So if we look at Padlet, and again, there's lots of tutorials on Padlet. I even have a, like I said, a reference slide at the end here. If you were to create a Padlet for a number talk, you can post the question, and then every student gets a chance to post their response. So this is another way to share screen in a synchronous setting and to allow your students to take their time to go ahead and post their answers. So again, some of you may have used Padlet, and hopefully you have some ideas sparking, and I do want to hear them when we open that part of this presentation up. Another possibility that I have been playing with recently is Google Drawings. So this is available in your G Suite tools, and it is a wonderful way to just insert let me see if I can remember how to do this here. If you can just go ahead and create lines to draw things. If you wanted to say, okay, I visualize this as a triangle of sorts. If we're thinking of a fraction problem, you can actually use drawing tools, which, here we go. I am totally forgetting. Jamie, where's the drawing tools? You can tell I've done this a lot recently here. So
I am not 100% sure.
I had so much fun with these things. So there are I have a tutorial at the end, so I don't want to waste time on this, but I just want you to think about all the Tech Talks. If you've been part of our webinars, you have seen Tech Talks on different tools where you can use it as a drawing tool or Padlet or different ways that our students can join in to just even basically a Word document. You could create a Google Doc, a shared Google Doc, and students can go ahead and actually put their thinking in real time in a synchronous setting. So I want to hear what ideas you come up with that you could do to capture students' defense of their answer. So think outside the box. I have hopefully in this presentation have shared with you why there's value in continuing these number talks for our students learning and increasing their skill in their mathematical foundation and thinking and number sense. And now it's a matter of thinking creatively about how we can bring those online. So how can you imagine incorporating this into your current delivery model? Like, I'd love to hear from you guys now. So I've got a few more of you here. I also want to know, what challenges do you foresee? Because I'm just kind of getting into doing this in an online setting, but and we're all colleagues here. Let's collaborate on that. If there's a challenge, maybe I have an idea on how to address that challenge, or another one of our colleagues online here do too. So can you please share in the chat the answers to these questions for me? And Jamie, let me know if anybody has anything to say. And you're welcome to also let us know if you would rather speak about it. Jamie, we have the capacity to have you use your microphone.
Yes, absolutely.
Thank you.
And so nothing's coming in the chat. Of course, you know, people need some time to type, but as Jane said, please feel free to unmute and verbally answer these questions. And if they do come in the chat, I will read them off.
Thank you.
So Kylie says, thanks, Jane. I'm reinvigorated. I've been successful in getting some number talks on Google Classroom, but struggling to get students to engage with each other. I like the idea of Padlet.
That's great, Kylie. And I'm, again, I have been using a limited number of tools, and Kylie, you've used a lot of tools that I know of with your students. Is there something like Padlet that you could also recommend, and Bill and Nancy as well? Is there any other tools that you can think of? I'd love to hear what else you think.
Bill says Padlet is something I will try, and looks like it will encourage discussion. And I think we lost Nancy a little bit in there. So.
Can you hear me?
Kylie. Yes. Hi, Kylie.
Hi. I have tried using like a shared Google Doc, but I think students just they're not quite comfortable or knowledgeable about how to collaborate on those. And so I think I need to incorporate some sort of training, or just encourage them, you know, show them maybe even how to comment on each other's work, or how to, or actually require. I liked that you required that students did on at least 2 people's work. So I think I could add those 2 pieces, just more training on the actual tool, and then actually requiring them before they turn in their assignment to look at other people's work.
Mm-hmm. It's interesting because I think when I have taught both HSE and higher ed, I have a tendency to feel nervous about requiring things for some reason in the HSC realm, because I'm not giving grades, right? But that idea of practice and reinforcement, and that if you think of the 4 C's work that some of us has done with training from the back of the room, we have to have that concrete practice and that reflection time and that connection. So they're all kind of very important to do. So I like that you brought up that sometimes it's the tool that needs to be discussed. definitely there's advantage to Padlet because it's an outside kind of link, and then they know they have to actually enter something. So that might be better than this stale kind of page. But there's wonderful tools out there that I'm sure other people can add to. And I hope those of you that are watching this video after the fact can, Jamie, is there comments possible when we post these to get more ideas to share as a community of learners? Okay.
Yes, people can
Great.
comment. One thing that Bill added in, and I think it goes along with what you all are talking about, is that digital skill training is a must. Or a plus, I'm sorry, not a must, a plus.
It might have to be a must. You might be right about that. Yeah, and some of the challenges I foresee is that idea that you mentioned, Kylie, is that we do tend to have some students that are lower level with digital skills, and it creates a little bit of a problem. I do want to say that some things that I didn't know if would come up, but I wanted to mention, if we are using the access we have to Nearpod, there are some great question tools in there that you can change the settings to allow for all students to see or for the post to be anonymous. So there's ways to take away some of the risk factors if you haven't established the ideas of taking risk. And if you don't feel like quite there's a community that everybody feels super safe in, even in an online setting, you can do something where their posts and their responses are anonymous for the sharing out. That doesn't mean that you don't see who they are. So that's one option, to look for tools that afford that sense of anonymity. So that's a good one. Another thing that's incorporated in the Google Slides, for example, and you can just do independently, is that Poll Everywhere. Have you guys tried Poll Everywhere? You can use that as a way to input in answers as well. So you haven't tried Poll Everywhere. I didn't put a tutorial on that, Bill, but because I just opened up the chat so I can kind of see what you're saying here. But I do think that that's a worthwhile one. So I think Poll Everywhere. And Jamie, you have a lot of experience with Poll Everywhere. Can you imagine it working with Number Talks in a synchronous setting?
I can, and you know, there's a way to incorporate Poll Everywhere into your Google Slides to where people can answer, but they won't see each other's answers until you make the slide visible. So that gives them the opportunity to really think and give their answers, and then you can call on students or maybe have them volunteer to explain their reasoning that way.
Wonderful. Yeah, so I think whatever tool you end up gravitating towards as a professional, use it, because if you're excited and comfortable with it, your students are going to be excited and comfortable with it too. And some of them have advantages and some of them have some challenges. So until you play with it a little bit or watch a lot of tutorials, there's some great tutorials out there, you guys. So hopefully that will help you. So I want to go back here. Oh, I just saw Bill's question. Is Padlet part of G Suite? Jamie, I'm going to defer to you. I don't believe that it is, but I do think there's an add-on you can do. Am I right about that, Jamie?
You know, I agree. I don't think that it's part of G Suite. I'm not sure if there's an add-on for slides. I know that there's a free version of Padlet. I just don't know if it's part of G Suite.
Okay, and I did apply for just the free basic version when I set mine up too. So even if it's not incorporated, thank you, Jamie. Then you can do the link the way I did in the in my slides, and it just brings you to that page. So I don't know. I'm sorry, Bill, that I don't have the exact answer for that, but I don't believe off the top of my head that it's part of the G Suite tools. Okay, so that being said, we have a few minutes for questions. I did put on this slide, if you guys have questions, please type them in the chat or unmute yourself, but there is my email. So please feel free to ask me or share any ideas you have. I'm teaching just like you all are in this new reality that we are finding ourselves in. So definitely sharing with colleagues is like Kylie used the word, reinvigorated. It's really gives us a little bit of fire when things seem a little bit disconnected. So these ways of using discussion posts, synchronous and asynchronous Number Talks, are another way of getting that engagement back up that we so love and crave from our face-to-face classes. So on the slide, I have a Padlet tutorial, a Google's drawing tutorial, and a Number Sense resource from YouCubed. YouCubed, you guys, if you take nothing else away from this and and you can do some research on your own. This particular site is so valuable. I'm actually going to share it while I wait for any questions. Ucubed. So this is a particular number sense page on Ucubed, and it has the videos of number talks, talks about the importance of number sense, shows it in elementary. So our challenge, I think, as HSC instructors is to take these tools and apply them to our adult student population. And it's really not that hard of a stretch as we think, but often we have to make our own videos and our own resources and our own questions to adapt it so that we don't feel as though we are sharing third grade material with our adults. That can be very condescending and challenging for our students, as many of you know. So I just wanted to show you that resource. And are there any questions, Jamie, before we run out of time here?
Bill just had a comment. He said, I find students are in awe of representing numbers by images. I first encountered that in dealing with base 16 in computers.
Base 16, wow, good to go. That's amazing. Yeah, I think I get pretty fascinated. Bill, too. Do you have a particular story you want to share before we go today? Is there anything that stuck out in your mind?
Only that when you did that, excuse me, first image where you had it look like a building and then a key, I would have done it just with the building and had the building represent 13. And then maybe in a later iteration of that, then break it down with the building and the key and say, okay, the building represents 10, the key represents 3. My level of students, they would have not attended or, done something else. It would have been too complex. I think we need to ease into it a little bit.
That's a very good point. And if you choose to pursue this and look online, just like I said, look up math riddles or math puzzles and choose the one that's appropriate for your level of students. There's even just basic images of dots and lines and having students count them in a flash on a screen, and then it shows how they're grouping numbers together. So you can take this to very basic levels. And that book that I showed on the very first slide is a wonderful resource, our Number Talk book by Ruth Parker and Kathy Humphrey right here, Making Number Talks Matter. There's some great actual concrete examples in there. But even without purchasing the book, there's some wonderful resources online for any level of students. I've even done this with some advanced college algebra students, and you can make them be very rich where they're trying to determine measurements of borders of different shapes. That takes a little bit more time. And the variations that you do with these number talks, as you do them in person or moving them online, which was the focus of today, can be adapted to fit any level of student. So that makes it really a creative way of teaching our mathematics, which I think is what makes it so rewarding. So if there's no more questions, we are, I believe, out of time, Jamie?
We are at 12:48, so This was, very, very good timing. Kylie says, thank you so much. Very good timing for me, as we're starting a new session. So keep up the good work and have a great day. Thank you, Kylie.
Thank you for being here, Kylie. I appreciate it. And Bill, thank you for joining us today as well.
Absolutely.
Nice to meet you.
And I'm going to stop the recording.
Okay. If anybody's interested in getting in touch with me after the fact, please feel free. Thanks, Jamie.